Hello friends, today we will discuss if GOF is injective then F is injective. Firstly, we will say that what is the definition of injectiveness. If we have x1 and x2 and F is the map from A to B. x1 and x2 is in A, which is such that x1 is not equals to x2, then F of x1 which is not equals to F of x2. Then it is said that F is an injective function. F, G, and so on. Okay, now assume GOF is such that A to C is an injective function when F is given by A to B and G is given by B to C. Assume to the contrary that F is, firstly we will assume that F is not injective, right? If we say that F is not injective, then F is not injective. There means that there exists x1, x2 is in A, right? It is in the domain of F, such that x1 is not equals to x2, which implies that f of x1 is equals to f of x2, because we will consider then F is not injective. If F is injective, then x1 is not equals to x2, which implies that f of x1 is not equals to f of x2, right? There is f of x1 is equals to f of x2. Apply both sides g to both sides g. This implies that g of f of x1 is equals to g of f of x2. By the definition of composition, this will implies that g of f of x1 which is equals to g of f of x2, because we will consider that g of s is injective, right? We will consider that this is given. So if it is given the g of f is injective, this implies that x1 is equals to x2. This contradicts the fact that what we have assumed that x1 is not equals to x2, right? So our assumption is that f is not injective is wrong. F must be injective. This implies that. Now, so by example that GOF is injective need not implies that G is injective. If GOF is injective, this does not implies that G is injective. Let us take A is equals to 1 and B is equals to 1, 2. F of A is equals to 1, G of 1 is equals to 2. J of F is equals to 2. F of 1 goes to 1. F of 2 also goes to 1. This is implies that F is not injective.